Hey guys, what's up? In this video, we are going to discuss sequences for patrons. In the previous videos, we have seen some sequences, and here actually we are given with different patrons. You can see here we have an 8-sided figure, here we have two 8-sided figures, here we have three 8-sided figures. So actually here we have a patron. And what we are doing in this video here, we will first of all we will draw a sequence table to find first 5 sequence of this patron. First 5 we can say elements. Okay, so of this patron, and then we are going to find the formula to calculate. We can say, you can see here we have actually small bars, or we can say small sticks we have. So here then we will find the formula to calculate the number of sticks, okay, in that pattern. Actually here this pattern is on the first position. We can say this is the first pattern, second one, third one. Okay, so it is according to its position. Clear? So let's get started. First of all, you can see here we have, in the first place, here we have a figure, and in that figure we can say it is made of 8 sticks. Okay, you can count 1 2 3 4 5 6 7 8. So here in the first figure, here are 8 sticks we have. In the second figure we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Here are 15 sticks. Similarly, in the third figure, here we have 22 sticks. Okay, these are sticks, and these, we can say, these are the positions we have. Okay, first of all, we will draw a sequence table for the first 5 patrons. Okay, so how we can draw it? Here I can write here patron number, okay, here means n. Okay, then what I will write here below, here I will write here number of sticks. Okay, it means that here if we have a first patron, mean this one, okay, here we have 8 sticks. In the second patron we have 15 sticks. Similarly, in the third patron we have 22 sticks. Similarly, we have to find it for the fourth and fifth patron. So how we can find it? Actually, it is a regular patron, we can say. It means that here, if I see the difference between this one and this one, there is a difference of 7 sticks. Okay, here we have 8 sticks and here we have 15 sticks. I want to say that here, if I subtract 8 from 15, or I can say that if I take the difference of it, here there is a difference of 7 sticks. Similarly, this one has 15 sticks and this one has 22 sticks. So if I take the difference between two, here it is also of 7 sticks. Okay, so that's what I mean, that here we can say it is a regular pattern. I mean to say that here the number of sticks are increasing in a regular way. After we can say here is a gap of 7 sticks. Okay, after every position, after every pattern, 7 sticks are going to be added here. Okay, so it means that if we have 8 sticks, if I add 7, I will get our next pattern which has 15 sticks. So if I add 7 into 15, I will get our next pattern, our third pattern, which has 22 sticks. Similarly, if I add 7 into 22, so it will be equal to 29 sticks. Okay, which is our fourth pattern. Okay, which will be our fourth pattern. Okay, you are getting my point? Similarly, if I add 7 into 29, okay, so here it will be equal to 36 sticks. Okay, and it will be our fifth pattern. Clear? It is our first, second, third, and the fourth one will contain 29 sticks, and the third one will contain here 36 sticks. Okay, you are getting all my points? So this is the sequence table. here I have written here the first five pattern of this one. Clear? The number of sticks. Okay. Alright, so here I have drawn the sequence table. Okay, now what I'm going to do here, I will drive a formula to calculate the number of sticks, we can say, in every pattern. Okay, actually the formula will remain same, just like in the previous video, that actually here it is our we can say it is our first pattern, second, third, fourth, fifth. Here the difference between these two is 7. Similarly, the difference between these two is 7. Okay, 7. So as I have told you earlier that here we have to apply the position to term rule. Why position to term rule? Because here first pattern, second, third, fourth, fifth, these are actually the positions of we can say the number of sticks we have. Okay, these are the positions, and according to that position we have corresponding number of sticks. So I have to apply here position to term rule, and it says that first of all here we will write a variable, let's say s. Okay, s for sticks, you can use any variable, and here if the difference is same I have to multiply that difference with 7 here with x. Okay, you're getting my point. And now we will check that here is this formula, okay, is this formula is giving us the correct answer or not. Okay, so first of all here let me check that here. If I take the first pattern, okay, if I take the first pattern, it has 8 sticks. Okay, so 7 here, 7 multiplied by let me take here n. Okay, let me take here n. Okay, n is more clear because actually n is representing here the sequence number, we can say. Okay, the pattern number. So here if we want to see the first pattern here, so we know that here it is the pattern. Okay, so I will write here because I am seeing the first pattern. So according to the first pattern, here this formula will give us 7. Okay, but here in actual our first pattern has 8 sticks. So I want to say that here if I add 7 into 1 I can get 8. Okay, I am adding 7 into the I am adding 1 into that formula, means here clearly 7 multiplied by n plus 1. Okay, 7 multiplied by 1 is equal to 7 and plus 1, so I will get 8, means 7 multiplied by 1 plus 1, it will be equal to 8. Okay, now this formula can give us the correct number of sticks. And you can also check any other term. Let's say here if we want to check the third pattern here, so here in third pattern we have 22 sticks. Okay, you can also get 22 sticks from this formula. You can check here that here we have 7, this is n. Okay, 7n plus 1, because here we have third pattern, so here we will put 3 instead of n. Okay, 7 3 is 21 plus 1, which is equal to 22 sticks. Okay, so here this formula is giving us the correct number of sticks on every pattern. So this is the formula, this is the nth term for this pattern, and from this formula we can calculate a number of sticks present at any pattern. Let's say here if we want to find the number of sticks on we can say 12th pattern, we can say in the 12th pattern, this is the first one, second one, third one, and the 12th pattern contains how much sticks. So here it's very easy, we just have to put here 12 instead of 7, sorry, instead of n here, like this one. So here 7 multiplied by 12, it is equal to 84, and plus 1, it will be equal to 85. So here we can say that on the 12th pattern the number of sticks will be 85. Okay, got it? Clear? So that's how we can say we use patterns in sequence. Okay, here we have seen how to find the formula. Okay, how to make a sequence table for the pattern. Alright, now let me show you some more questions here. Now here we have different patrons. First of all, you can see here we have only one dot, then here we have increased it, okay, one by one, means that here I have increased dot one on the right side, okay, one on the upper side. Then here, according to this one, I have increased one more dot here and here. Similarly, according to this one, here I have increased one dot in this one, so it will be this one. Okay, so this is the first pattern we have. This is the second, third, and fourth. If I count the dots here, so here in the first pattern we have only one dot. Here in the second pattern we have four dots. You can count 1 2 3 4. In the third pattern we have 9 dots. You can count. In the fourth pattern we have 16 dots. So here, if we want to find the formula here, the nth term here, from this, how we can find it? Okay, so it is the position term rule. We know that. Here, if you just observe the number of dots we have, so here we have 1 4 9 and 16. These are actually the squares of their patrons. Okay, first pattern, if we take the square of first pattern, so it will be 1, which is the number of dots we have. Here in the second pattern, if I take the square of 2, here I will get 4 dots. Similarly, if I take the square of the third pattern, 3, means here it will be equal to 9 dots. Then here in the fourth pattern, if I take the square of 4, it will be equal to 16. So actually you can see, we can say these are increasing in the form of squares. We can say in the first pattern we have only one dot, and then in the second pattern you can see one is increased from here and also here. Okay, so now it is a square. Similarly, 3 dots here, so 3 dots are present here, or we can say horizontally, and 3 dots are present vertically in the form of square. Similarly, in the fourth pattern we have 4 dots horizontally, 4 dots vertically, and it is present in a square. So here, if we have this kind of condition, here the nth term will be equal to the square of the patron. Here n is the patron. So here, if we take the square of patron, here I will get the total number of dots at a specific patron, okay, of a specific patron. We can say if we want to find the number of dots of 14th patron, so here just I have to take the square of 14. Okay, so it will be equal to 196. So 14th pattern will contain 196 dots. Got it? Similarly, like in this condition, here you can see here we have actually the area. Okay, because we know we can say here this one multiplied by this one. Okay, this one we have 4 dots here and 4 dots here, so 4 multiplied by 4. Okay, it is actually the formula of area. Okay, we can see this one multiplied by this one, so it will be the number of dots we have. It is actually the area. Okay, and here we can say here, if I just count the number of boxes in the patrons, now this is the type of volume, because here you can see here we have only one square. Actually it is not a square, it is a cube. Okay, here we have only one cube in the first pattern. Similarly, in the second pattern we have 8 cubes. You can count. Okay, this one is first, second, and below third and fourth. Similarly, fifth, sixth, okay, and below one, seventh, and here behind this it is 8. Okay, behind it it's 8. Okay, let's count again. First one, second one, third one, fourth one. Similarly, fifth one. Okay, this whole is fifth one, this behind one is sixth one. Okay, this seventh one, and one is present behind eighth one. So here in the second pattern we have 8 cubes. Okay, so here we have 27 cubes. You can also count it. Okay, first one, second one, third one. Okay, fourth one, fifth one, sixth one, seventh, eighth, ninth. Okay, and then 11th, 12th, 13th, 14th, 15th, and 2 boxes behind this one and behind this one. So 16, 17, 18, 19. Similarly, 20, 21, 22. Okay, this one is 22, 23, 24. Similarly, 2 boxes behind this one and this one. So 24, 25, 26, 27. So here we have 27 boxes. So if I want to find the formula here, we can see the nth term here. How we can find, here in the first pattern we have 1 cube, here in the second pattern we have 8 cubes, here in the third pattern we have 27 cubes. So actually you can notice here that here these are the cubes of their patterns numbers. Okay, the cube of 1, it is equal to 1, the cube of 2, it is equal to 8, the cube of 3, it is equal to 27. So here we have taken the cube of their pattern, of their corresponding pattern, so we will get the number of cubes here. Or, and actually it is the volume, we can say, let me here draw. Okay, we can say if it is the length, we can say, okay, wait a minute, okay, this one, and this one. Okay, if this is the length, if this is the breadth, if this is the height, so length multiplied by breadth multiplied by height, it will be the volume. Similarly, here we have 3 cubes here, 3 cubes here, and 3 cubes here. So 3 multiplied by 3 multiplied by 3, it will be equal to 27. So this is an example of volume. Got it? So if we have such kind of questions, so here we are going to take the cube of their positions, of their pattern. Clear? So I hope you're getting all my points here. So that's it for this video, sequences for patterns.
Access the entire Mathematics Demystified course at learneasy.us.